Imagine 1,000 users open your app at the same time, but all requests go to just one server. It slows down, and then crashes. So we scale by adding more servers. Now we have multiple machines ready to handle requests. But now there's a new problem. How do we decide which request goes to which server? This is where a load balancer comes in. It sits between users and servers, acting as a single entry point, and distributes incoming traffic intelligently. Instead of users directly hitting servers, all requests go through the load balancer. Now, how does it decide where to send each request? It uses different algorithms. The simplest one is round robin. Requests are distributed one by one across all servers in order. First request to server 1, second to server 2, third to server 3, and then it repeats. It's simple, but it doesn't consider server load. A smarter approach is least connections. Here, the request is sent to the server with the least number of active users. So traffic is distributed more evenly, especially when some requests take longer than others. Another method is IP hash. Here, the same user always goes to the same server. This is useful for session persistence, where a user needs to stay connected to a specific server. But in real systems, not all servers are equal. Some are more powerful than others. So we send more traffic to stronger servers. This is called weighted load balancing. Now, here's something critical. How does the load balancer know if a server is down? It continuously performs health checks. If a server fails, it automatically stops sending traffic to it. This is what makes systems reliable. Without load balancing, one server gets overloaded while others sit idle. With load balancing, traffic is evenly distributed. This gives you better performance, high availability, and fault tolerance. Even if one server goes down, your system continues to work. Now let's look at two important types of load balancing. Layer 4 load balancing works at the network level. It routes traffic based on IP address and port. It's very fast, but it doesn't understand what's inside the request. Layer 7 load balancing works at the application level. It can actually look inside the request and make smarter decisions. For example, requests to /API can go to one server, and requests to /images can go to another. This makes it far more flexible, and it's what most modern systems use. Load balancers also come in different forms. Some are hardware devices, but most modern systems use software load balancers running on servers. In real-world systems, load balancing is everywhere. Tools like Nginx, HAProxy, and cloud services like AWS load balancers are used to handle massive traffic. And here's the key idea. Scaling is not just about adding more servers. It's about how intelligently you distribute traffic. And that is what load balancing really solves. Subscribe for more simple explanations on system design.